Hello there. My name is Jasmine. I am a persona from Persona Labs. Today Sam is going to talk to you about some of the latest developments in AI from Google. Last night I learned to speak Thai a little bit. Let me try that now.
สวัสดีค่ะฉันชื่อจัสมินฉันเป็นเพอร์โซน่าของ Red Dragon AI วันนี้คุณแซมจะบอกว่ามีอะไรที่ใหม่ๆใน AI ของ Google ถ้ามีคำถามถามได้เป็นภาษาไทยค่ะ
Hopefully my pronunciation wasn't too bad. Let me now pass it to Sam to take over.
Okay, so that's one of the things that I work on day to day. We're making digital people and creating sort of. She's fully live and real time. All right, let me get started. Okay, so quickly, just a bit about me. As O said, I'm a GDE for ML and deep learning. I specialize mostly around things to do with dialogue systems and generative models. I'm also one of the Google for Startup mentors for North America and for Asia. I've built multiple startups, including 2 B2C startups with more than 1 million users. All right. The startup that I'm working on at the moment is called Red Dragon. We do a bunch of different things. We're a Google partner. We also do a lot of research, a lot of AI research, and some of the stuff I'm going to be talking about today is actually sort of more research-based stuff. And we also do, as you saw, the idea of digital personas. So, ชาติที่แล้วผมเคยอยู่ที่เมืองไทยนะครับผมพูดภาษาไทยได้แล้วถ้ามีคนใครอยากถามเป็นภาษาไทยผมยินดีที่จะตอบนะครับ But I'm going to speak in English for now. All right, so I'm going to focus on 3 things today from ML and from AI, just to sort of show you, tell you a little bit about some of the things that are happening, and then show you some of the sort of research and some of the directions things are going. So even if you're not an AI dev per se, a lot of these things are going to start popping up over the next year, 2 years, and you're going to start seeing them, in your sort of programming, in what you're doing more and more. The first one is a thing called Coral. So Coral's actually a few years old now, and basically this is sort of Google's attempt at making custom hardware to run machine learning models. And one of the problems that they've had is that you want to sort of be able to do something where you can run some kind of machine learning or deep learning model, but you don't want it to use a lot of power. And when we're talking about sort of like edge devices, we're seeing that machine learning is moving 2 directions. It's either going to the cloud, where things are getting really, really big, or it's going to the edge, where things are getting really, really small. And so we've had talks today about Android and stuff like that. Things are getting even smaller than that. So up until now, generally, people have had to make custom hardware to do this. So if you think about, Google Assistant, the sort of like Google speakers, I'm sure you've got these in Thailand as well, where someone can say, hey, I won't say it, everyone's phone will go off. The way that those things work is that they have multiple chipsets going on where you have one that doesn't use much power to listen for that keyword, and then that turns on the main chipset to actually do the converting from speech to text, etc. So this is quite a common problem, though, is that how do you do that if you're not Google? How do you do something where you want to have maybe a camera looking for something, but it's going to be on 24 hours a day, and you don't want to burn through a battery or something like that? So the latest thing that Google's announced for this is basically a new piece of hardware that in the sort of what they call the Coral group that actually does this, and it does it by having multiple boards here, so that they've basically got a sort of a micro board that starts out with this sort of M4 core model. So this is using a special type of TensorFlow that is what we call TensorFlow Micro. So the models here, we're looking at models of maybe like 6K, right? These are tiny little models. And that could be just simply looking for, is there a person in the picture? So you see the picture on the left, there's no person. There's a picture on the right, there is a person. In this case, they want to actually work out, what's the position of the person. So as soon as the first model sees that there's a person there, it then kicks in the second model where the M7 sort of wakes up, and then it can run a much bigger model. And obviously that's going to use more power, etc. So you then get something like this where it basically can stay in this loop, see what it needs, and then close down when it doesn't actually see that. So this is the new board that's coming out. It's kind of a little bit similar in size to a Raspberry Pi Pico. I don't know if people have seen those things before. It's got both a camera on it and a microphone on it, so that you can run it, straight out. The smaller chipset can run TensorFlow Micro models. The biggest set can run TensorFlow Lite models. So if you've already done anything for TensorFlow for Android or something like that, you can use a lot of those models for the TensorFlow Lite part of it that's going on here. The next thing with this is that you can basically use this tiny form factor anywhere, and Google's trying to get people to start prototyping ideas with these things, so that then they can then take it and actually turn it into sort of a hardware to produce at scale, etc. It's also fully expandable too. So there are sort of announced currently a couple of expansion boards for this. One is basically just a Wi-Fi board, so that if you wanted it to actually report something over Wi-Fi or something like that, it can do that. The other one is like a power over Ethernet sort of add-on to it, so that you can just leave these things on permanently. So more and more, we're seeing with sort of like the Internet of Things, where people make these things really cheap, and you have like hundreds of them maybe around a building, and you don't care when one of them breaks, right? The idea is that you've got sort of mass coverage of things, and then you've got very small models to do really useful sort of tasks here. So Google's just announced this. It's not quite out yet, but it's coming soon. They've also got, you're going to be able to buy some enclosures for it if you want to get a case. For the first time, I think they're also releasing like a 3D, a 3D printing sort of model that you can then download and customize it and stuff yourself if you wanted to make your own case for this. The key thing, with this whole thing is just to sort of realize that this is one of the directions that machine learning is going, and one of the directions that deep learning is going, is this whole sort of thing at the edge. So as programmers, as developers, as engineers, you should be constantly thinking, like, if there's an opportunity to use something like this is available now. And it's getting to the point now where you can quite easily make your model in TensorFlow, convert it to TensorFlow Lite, convert it to TensorFlow Micro, and put it on one of these devices or one of the other Coral devices for doing this. So, like I said, things are forking. They've gone, to the edge on one side, and on the other side, they're going really, really big. So this is what I'm going to sort of focus on mostly for the rest of the talk, is the idea of these large language models, and some of the latest research around these large language models, and to sort of show you just some of the things that they can do. So what is a large language model? Anyone heard of language models before? All right. We've got maybe 3 hands in the room. Okay, so the language models generally break down, and I'm simplifying things a little bit today, but generally break down to 2 types of models. We've got what we call autoregressive models, which is where you're just predicting the next word all the time. So you can see that here we're feeding in a word, and then as it goes through, it will predict the next word in the sequence. This, while it's a very simple task, it turns out that this becomes really, really useful for a bunch of things. So this is the first one. How many have heard of GPT-3? Have people heard about that? Yes. Okay, more people hands up with that. So GPT-3 is an autoregressive model, right? The second kind of model is what we call a masked language model. And these models are trained to sort of fill in the blanks. So you can see that we've got certain tokens, what we call tokens here, that would be masked out. And the model has to learn to predict what to put in these. Now, these two types, and this one is quite, has a famous one. It's called the BERT model. So these two types of models, it turns out that when you train them, even though they're just such simple little tasks, when you train them with billions of words and with a lot of compute, they kind of learn language, and they get really good at it. And they get good at it at being able to sort of understand, and I say understand in inverted commas, because it's not like the way you would or I would understand things, but they get very good at being able to predict different things about language. And we're sort of in the middle now of this sort of boom in natural language processing that's going on, right? Basically because of these two types of models. So if we look at the sort of, some of you said that you knew what GPT-3 was. So let me go back just a little bit to GPT-2, which is now probably 3 or 4 years ago. Back then, GPT-2, the size of the model was huge, right? Was absolutely huge. It had 1.6 billion parameters. And for anyone, doing machine learning at that time, it was like, wow, this thing's so big. I can't run it on my GPU card, in my computer or anything like that. And I want to sort of show you how fast these things are growing. So the 1.6 billion one doesn't even make it on my chart today, right? I'm starting off with one that I'm going to talk about a lot, which is Lambda, which is 137 billion parameters. You can see GPT-3 we talked about is 175 billion parameters. We've got Gopher, which came out from DeepMind. And the one that I'm going to focus on today is Palm, right? So apart from Palm, we also have a model called Glam from Google and a model called Wudao from one of the research groups in China. These two really big ones are actually a little bit different in that they're doing what's called sparse activation. So they're only ever using about 10% of their full size at any one point in time. Whereas the Palm one there, 540 billion, is using the whole thing at any one point in time. So this is what we call a dense language model here. So Palm has just been sort of, was announced earlier this year. It was talked about a lot at Google I/O this year. And it's kind of becoming Google's de facto model for anything to do with natural language processing. So in the past, they were using BERT for doing a lot of things like Google search, a lot of modifications on that kind of thing for almost any task that you see. And now they're gradually sort of starting to move into using this. So where do you see this in Google products? If you've seen things like the sentence completion in Google Docs, right, or any of those sorts of things, you're seeing those language models in action for those kind of things. So pathways, you can see this is like these are all people that are working at Google Brain. It's one of the biggest projects that they've done at Google Brain for quite a long time. You can see just the research paper alone has so many different authors on this. And then to train this up, so I think Nongfon this morning talked about the TPUs and that Google's giving people access to version 4 TPUs. So one TPU board, right? These boards are about so big by so big. Has 8 cores on it. Then they take those and they build them into pods, which is basically, stacking them really high, and they're the only thing inside of Google data centers that is liquid cooled, right? Up until the TPUs, Google never wanted to use liquid cooling just because it caused, so many other issues. So this model is trained on 2 pods of TPU-4s. So it's actually got 6,144 cores going on. So 6,144 chips, you could think of it like that. And it's trained for a long time, right? This is not something that these things kind of run. This is basically a supercomputer. In fact, it's probably one of the world's top 10 supercomputers for this kind of thing. And you can actually rent them out nowadays. They're not cheap, I will tell you that, right? They're quite expensive to rent out. But this trained for quite a long time. And sure enough, at the end of the training, this thing basically causes the Palm model to get state-of-the-art performance on all these different tasks. So from things like question answering, from natural language inference, a whole bunch of different sort of NLP tasks. Palm is also multilingual, so it can understand languages far beyond English. And the move is more and more to make these models understand as many languages as possible. For the simple reason that if we're going for sort of a higher level of artificial general intelligence or something like that, you want it to be able to understand multiple languages. And also to understand multiple modalities, meaning images and other things as well as just purely text. So how do they use these things? They use these things with a new kind of sort of coding, and this is called prompting. So the prompting is like this. You put in some natural language text into it, and then the model will sort of predict using that and then keep predicting the next words to then complete the text. So if you look at the top here, we can ask it to explain a joke. You can give it this joke that, did you see that Google just hired an eloquent whale for their TPU team? It showed them how to communicate between 2 different pods, right? Hopefully you get the joke. So the model's response, right? Now the model has obviously, read billions and billions of tokens, or billions and billions of words, you can think of it like that. It then predicts out that, okay, to explain this joke, TPUs are a computer chip that Google uses for deep learning. A pod is a group of TPUs. And then a pod is also a group of whales. So it's able to work out that just from having, not having seen this joke before or having read this joke before, but just from having absorbed, enough things through the information that it's taken in. Some other points for this to sort of show you. Here are some prompts on things. So if you can ask it ones about cause and effect, and it can start to look at text and work out from cause and effect what's going on. It can do things like it understands synonyms. So here's an example of where if we give it the word stumble and we give it a whole bunch of different words, which words are most like stumble? And it says fall or trip. So it has, and I keep saying the word understanding, but I'll say it in inverted commas, because it's different understanding than perhaps we have, but it is pretty amazing of what it's able to do for this kind of thing. The other interesting thing that they've found was that for certain tasks, there are certain tasks that are harder than other tasks, right? So if I ask you a synonym thing, probably you're going to know a lot of those. Maybe that's not the most obvious, that's not the hardest task. But for certain tasks, it turns out that they only kick in when the model gets to a certain point. So you can see they train up different sizes of these models so that earlier on they're at 8 billion parameters. It then gets to like 62 billion parameters, and then we've got the full 540. And you can see that certain tasks really aren't going anywhere until, like if we look at this logical sequence task, it isn't really going anywhere until it starts to get to the bigger model. So it does kind of show us that one of the pathways, which this model is also known as, to sort of like an artificial general intelligence or something along those lines, is probably going to be size and making these, huge compute things. So the other thing that they also did with this paper, which was really interesting for the first time, was the idea of explainability. So this is what's called chain of thought prompting. So rather than just put some words and say, and ask it a question or something and get the answer, we also want it to be able to explain its answer to us. So the idea here is that basically it's sort of fine-tuned and trained to be able to take some sort of input in. You can see on the left is the standard prompting where it'll just give us the answer. And on the right is the where it actually sort of breaks down how it gets to that answer. It turns out that this is becoming really important because what it sort of shows us is where these things are getting things wrong. So, if I ask you, how old is Barack Obama? And you've never heard of Barack Obama before, that's what we call like a two-hop question, meaning first you have to work out who Barack Obama is, then you have to work out, how old he is. So you'll sort of see that these things gradually, so we could sort of see with chain of thought prompting where it's getting things wrong, when it's getting things wrong. And it also turns out that it makes it easier because then the sort of algorithm itself can almost start to think about who is Barack Obama, how old is this person. Now this also then starts to join in with some of the things that we'll see in this Lambda model in a moment. Another one is program synthesis. So this exact same model can also read code. Right, so in everything that it's taken in, it's not just taking things in language as in English or French or Thai or something like that. It's also learning about different coding things. So giving it some kind of description for a function, it can then start to generate this. Now this has still got a long way to go. It's not by it's certainly not going to replace coders at the moment, but it is kind of interesting where it's going. All right, one of the areas that this is becoming most interesting is the whole area of conversational AI. And this is something that at Red Dragon we've been really interested in working on, and at Google also. So at Google they started out 2 years ago with a paper called MENA, where they were looking at this idea of could you train up something that will have a conversation with people. And then over the past 2 years, they've had Lambda, which came out, which they first started talking about last year at I/O, but only released the sort of academic paper about it earlier this year. And then at I/O this year, they've talked about Lambda 2. So what I thought I'd do is just show you quickly an example of the first Lambda. So this is Sundar talking to it, or someone talking to it about Pluto.
Let's listen to a conversation the team had with Pluto a few days ago.
I'm so curious about you.
I sense your excitement. Ask me anything.
Tell me what I would see if I visited.
You would get to see a massive canyon, some frozen icebergs, geysers, and some craters.
It sounds beautiful.
I assure you it is worth the trip. However, you need to bring your coat, because it gets really cold.
I'll keep that in mind. Hey, I was wondering, have you ever had any visitors?
Yes, I have had some. The most notable was New Horizons, the spacecraft that visited me.
That must have been exciting.
The team that created New Horizons was very excited to see me. I also sent them back a picture of myself since I had not been seen up close before.
That's so great. What else do you wish people knew about you?
I wish people knew that I am not just a random ice ball. I am actually a beautiful planet.
Well, I think you're beautiful.
I am glad to hear that. I don't get the recognition I deserve. Sometimes people refer to me as just a dwarf planet.
Don't let it bother you. You're amazing.
Thank you for the kind words. I appreciate it.
Thanks for talking with me.
Okay, so that just gives you a small taste of, of the kind of thing that it can do. So all that dialogue, that it was answering, it's generating all of that by itself, right? Just using the weights in the model. And it also has sort of a little bit of access to, to facts. So if you asked it a fact, it turns out they have a whole system that it can start using for looking facts up. Let me just go on. So just to sort of show you, like again, this is one of the very big, projects that Google's been working on. It's built on what's called a transformer architecture. It's trained to mimic real-world conversations. So you're really at the point now where you shouldn't, if you were talking to it as a person, you probably wouldn't know that you were talking to an algorithm and not a real person. Hence why Google's very big on the whole safety aspect. They don't let you just talk to a person. They let you talk to an inanimate object, like Pluto. There's another one where you can talk to a paper plane, right? The idea is that they don't want people trying to use this to, for some sort of harm or something like that. It uses this idea of sort of retrieval-aided dialogue as well, meaning that if it gets to a point where it doesn't know something, it can actually look out on the internet and find what that fact is. So obviously Google's very good at search. It has a module that lets it go and do that kind of thing. And so you could, ask it anything about sort of Wikipedia, these kind of things. It also, we're looking at something that's trained on sort of 1.12 billion dialogues for this kind of thing. So it's pretty amazing, what it can do. Like I said, at I/O this year, they announced Lambda 2. So there's no paper yet for Lambda 2. We don't even know if there will be a paper yet for Lambda 2. But it's pretty safe to sort of make some educated guesses about this. Lambda 2 is probably a lot bigger than Lambda 1, than the one that I just showed you. Also, in the meantime, people have gotten very much better at making optimizing the training of these things so that you actually don't even need as big a model as you did before to get the same result. So it's not like that it's just going to be 4 times better before. It's going to be a lot more than that. It's most likely using the Palm model or something along the size, the size of the Palm model. And it's using different kinds of prompting tasks and stuff like that. So one of the things that they've realized now is that you can actually train these things to get good at explaining things much more. So this is something that Google's debating about how they release it. There are 3 apps that they're going to sort of make access over the next few months. And if you go to this, if you keep looking at this AI test kitchen .withgoogle.com, you will gradually see these apps become available. The first one is they call it Imagine It. And it's basically you just ask the thing to imagine something, and it can then have a conversation with you about that. All of these things are deliberately limited, right? In that they don't want someone coming along and saying, imagine Donald Trump taking over the world or something like that, right? They're kind of limited to sort of more surreal, fiction sort of ideas. So this is the first one. The second one is List It. So List It is kind of like, imagine having a really smart personal assistant that you say, hey, I want to have a birthday party this weekend. What do I need to get? And it will go through with you and work out, a list of all the things that, it will suggest things. And you could imagine that it's not just for things like birthday parties. You could say, right, my company is launching this new product, and we're going to launch on Facebook, TikTok, and Twitter or something. What do we need to do? And it can start to list out ideas for you. So the idea here is that it's helping you to sort of generate new ideas for different kinds of things. And then finally, the last one is a talk about it. This one, as far as I know, this one at the moment is only going to be limited to dogs. So you can kind of talk about anything about dogs, right? And the model will have a conversation with you about that. And it's kind of funny that if you try and steer it away from dogs, it will try to bring the conversation back to dogs. But anyway, the key thing I wanted to sort of show you with this is just how good this stuff is getting, and that you're going to start seeing these things show up over the next year or two in products and in a lot of things with Google. Another one that Google just announced sort of 2 weeks ago, remember I talked about multimodal ideas, is that these kind of AIs really are not just about words, they can also do images as well. So this is one that Google released, I think about 2 weeks ago from memory. And this is image gen. So what this basically does is you write in a caption and it will generate the image. So this is not a real image, right? This image is made by an AI. And you can see that what the person wrote in was a photo of a corgi dog riding a bike in Times Square. It is wearing sunglasses and a beach hat. And sure enough, it can then draw something like this, or can render something like this. Let's look at, I've got a couple of other ones. So, okay, this is how it does it. It uses a language model in there to encode. So it's kind of trained up to learn that, lots of different pictures, what they look like. And you could imagine if it sees enough captions of corgi dogs, it's able to work out, oh, this is the corgi dog part, right? And this is what blue means, and this is what green means, and this is what all these words mean. And then gradually it can then be done in reverse to generate images out for this. So let's look at some of them. So here are some ones. These are all rendered from the algorithm, right? A single beam of light enters the room from the ceiling. The beam of light is illuminating an easel. There's a Rembrandt painting of a raccoon, right? As far as I know, Rembrandt never painted a raccoon. They're pretty good at being able to sort of copy styles. A majestic oil painting of a raccoon queen. Again, the AI has done this all by itself. Raccoons going into space. A photo of a raccoon wearing an astronaut helmet looking out the window at night. So you think about it, there's probably no image of that in the real world, right? Before an AI made that. I don't think anyone got a real raccoon and put an astronaut's helmet on it. So the algorithms had to learn what a raccoon is, what an astronaut's helmet is, what images are like looking out a window, right? And then at night as well, to be able to render all this. And then you can see last one, the Toronto skyline with Google Brain logo written in fireworks. So you will definitely see this kind of thing in products over the next couple of years. And yeah, if you were an artist just doing boring art for an advertising agency, your job might be not as valuable anymore. Here's some of the ones I like. This one is really cool. A marble statue of a koala DJ. Again, I don't think there's a real-world picture of that for it to learn from. And then 2 robots basically having dinner at the Eiffel Tower. So this is sort of the research stuff that I just wanted to give you a taste of, like what's gradually coming out and is going to make its way into products over the next couple of years. If you're interested in making this stuff, right? If you're interested in sort of getting into ML and deep learning, Google actually has a new framework for deep learning, and for all these models now are no longer being done on TensorFlow. Right, they're being done on a different kind of framework. So let me just go quickly through a little bit of the history of deep learning frameworks. So how many people know Numpy? Any Python coders? Yeah, okay, I'm seeing quite a few hands. So Numpy's been around since 1995. Is a very good mathematical operations library, etc. for Python. But obviously it wasn't built for deep learning or something like that. Over the time, we've seen things that were. Torch was probably one of the first ones in 2002, has been updated. Keras, maybe some people know that, came out in 2015. If we go forward to sort of sort of the original ideas of TensorFlow were around 2014 inside Google and then coming out in 2015 for the public. PyTorch came along in 2016, and we've gradually seen these things come along. And then sort of around 2019, Google was starting to think of a new framework. And they actually released a few different ideas, and one of the key ones was this idea of this thing called JAX. And JAX and Flax are now the two sort of things for developing a lot of these models. So let me just quickly go through those. So JAX was basically introduced in 2019. It really didn't start taking off though until last year. Probably over the pandemic, it gradually started to take off. This is an open source framework, more so than TensorFlow. TensorFlow is kind of built for Google's things in production, and if you can use it, great, you can use it. But if you've got a great idea to make it better that would change how Google works, they're probably not going to accept that idea, right? I don't think of it that much as being open source, whereas JAX and Flax are, right? A lot of the team who developed this also are the people who developed PyTorch. So you're sort of seeing this take off. This has got all your standard sort of deep learning stuff like autograd, automatic differentiation stuff. It's actually built to be just like Numpy, but to run on accelerators. And when we say accelerators, we're talking about not just things like GPUs, but TPUs and the TPU pods. So you don't need to change your code that much to be able to scale from your CPU on your laptop to a supercomputer. And that's something that's key. That's one of the things that probably TensorFlow failed at for a long time, was being able to take your code that you write on your laptop or for a single accelerator and try and scale it up for something much bigger. But in the background, it is making use of some of the low-level TensorFlow stuff. So XLA is actually what drives the low end of TensorFlow. They're using that as well, but it just compiles it in a much better way. So if you look at JAX code versus Numpy code, you will see that there's almost no difference, right? The sort of the standard thing is just importing jax.numpy as JNP rather than just importing numpy as NP. And a lot of the things, it turns out, they're exactly the same. One of the differences is in Numpy we have an ND array. In JAX we have what's called a device array. So a device array is basically agnostic to any device that it goes on. It makes use of a lot of sort of compiler tricks. So tracing and just-in-time tracing. This is basically looking at whatever function you write and working out, can I do it in a better way than the person wrote it? So if you think about it, let's say you said, right, I'm going to take a number, I'm going to multiply it by 10, I'm going to square it, I'm going to do these sorts of things. And while for you that might be a logical way, or for a human that might be a logical way to think about doing that, the machine can probably work out a better way to fuse those operations to make them more efficient. And that's one of the key things in JAX is that it's basically doing this kind of thing, and can do it on the fly and can then do it to be able to scale it. Another thing that's really interesting with these things, well, let me go back, is the whole sort of idea of pseudo-random number generators. So if you've ever gotten into any sort of thing where you're dealing with random numbers a lot, you will find that actually computers are not very good at random numbers, right? And the way that people this is why we call it pseudo-random numbers. When you just do, your random.int, you might think that's really random, but it turns out that's not really random. And so what they do in this is they basically sort of say, well, let's say we abandon some of the old ideas of doing this thing, and we go for some new ideas of how we do it, so that you end up having these seeds that will always give you the same random numbers. But what you can do is create a new seed based on the old seed to get you a new random number. So that's kind of a little bit what Numpy would do, and what JavaScript, etc., would do for creating these things. It turns out this way, though, is really good for reproducibility. So if you want to test out different ways to optimize something or something like that, you really want to have the whole sort of reproducibility on your side. So JAX is the low-level mathematical library, the equivalent of sort of Numpy. Flax is the high-level API for building deep learning models. So this is what we call flexible JAX. You could think of it a little bit like Keras or PyTorch that sits on top of JAX, right? And it makes it easier. It has like all your, the stuff for building neural networks, all the sort of standard tools if you've used TensorFlow or PyTorch before. It actually uses a sort of API that comes from PyTorch, which PyTorch copied from another framework called Chainer. And this is the idea of subclassing API. So if you've done TensorFlow, any sort of advanced TensorFlow, you will have come across this kind of thing. But it turns out it's quite easy for us to write a definition of a neural network and then take this and basically spin it up across a pod, or even just like a number of GPUs that we want to do something on. This makes it really easy for building these models. So if you are interested in getting involved in this sort of stuff, definitely check out Flax and JAX. Another thing I was going to say is that this Flax also uses a thing called Opdax, which is basically just an optimization library from DeepMind. That has now become the sort of standard. This stack that I'm talking about, this sort of JAX plus Flax plus Opdax, does get a bit annoying that they all rhyme, but anyway, this stack is now kind of become default only in the past 6 months or so. Really maybe the past 6 months to maybe a year that we've seen these things now become the default stack for making all this new stuff going forward. Even though JAX was out in 2019, there are probably another 10 libraries that didn't make it, right? Of where people tried different ideas and it didn't make it, and it didn't become the way of doing it. If you're interested in doing this, check out, one more thing I was going to say. Okay, the other big difference to explain this, for those of you who know, is that these models, when you build a model, you actually separate the state of the model and the model itself. Meaning that your weights for your neural network is not stored in the model, it's stored as an immutable dictionary. And it turns out that doing that makes it, one, much easier for reproducibility, and two, just makes it much faster for doing this kind of thing. So if you're interested in that, here's a link that you can sort of get started with Flax. It's right at, it's definitely still at the very early days of this kind of thing. Like I said, the sort of stack has really only been finalized recently. But if you are interested in doing more sort of AI kind of thing, it's definitely worth checking out for this. With that, thank you. And I'm happy to answer any questions if people have questions. All right.